Okay, guys, so in this lesson, we'll be looking at steps to using equations. Okay, so this is what we'll be focusing in this lesson: steps to using these equations, ladies and gentlemen. I hope you've got something to write. Okay, so what I'm basically going to be teaching in this lesson is just firstly to explain the difference between the new and the old symbols, and then from there I'm going to take you through some steps to using these equations, and lastly I'm just going to take you through some important concepts that you need to be aware of in relation to these formulas. Okay, so ladies and gentlemen, I hope you've got something to write. Please do make sure that as I write, you just listen. As I've indicated in the previous lessons, that it's best to just watch this lesson for the first time by just listening and seeing what I'll be doing. You watch it for the second time where you try to apply your mind and of course try to understand what I'll be explaining. And then lastly, that's where you can watch it for the third time, which is a situation where you'll then be writing some notes. From there, ladies and gentlemen, you are advised to start tackling exam related questions. Okay, very, very much important, ladies and gentlemen. So remember, guys, I'll always indicate to you that a day without learning something new, it's a day wasted. So please do make sure that in each and every lesson that I do, you learn something new. Okay, and again, I will try to move as slow as possible so that we don't lose each other. Remember, ladies and gentlemen, we're still focusing on vertical projectile motion. Okay, so now we focus on motion in one dimension. So ladies and gentlemen, I hope you are able to see, to clearly see those equations over there. Okay, so I'm just quickly going to write the old symbols, which means all of this represents the new symbols. Okay, so in the olden days, ladies and gentlemen, we had just a V, which represents the final velocity. Okay, this was equated to U. U represented initial velocity. Okay, so that means what I'm writing here is what I've written there. So whatever that I write differently, it means previously it was represented differently. Okay, so ladies and gentlemen, the major difference on that equation is that you had your V, which represented the final velocity. You had U, which represented initial velocity. This was added to acceleration multiplied by time. Okay, very, very much important, ladies and gentlemen. Remember, guys, I think this is a stage where I now need to explain to you the difference in terms of, let's say, acceleration versus g in some equations, and again explain to you delta x versus delta y. So ladies and gentlemen, these are one of those easy things. I hope some of you already understand exactly what the difference is. Remember, guys, in grade 10 we focus on objects moving either from left to right or from right to left. Okay, remember on the Cartesian plane, ladies and gentlemen, we had the y-axis and the x-axis. Okay, so in grade 10, ladies and gentlemen, in grade 10 we focus on objects moving horizontally. Okay, which means, ladies and gentlemen, this is the horizontal line. That's why the distance is represented by delta x, or change in x, or just x. Okay, so that's why we had x. Very, very much important, ladies and gentlemen. So now in terms of acceleration, ladies and gentlemen, we had a, which means for objects moving horizontally, moving from left to right, either from right to left, or otherwise from west to east, or from east to west, that's when we use acceleration as A. Okay, because obviously for a car which is moving horizontally, it needs some energy for it to accelerate. Okay, very, very much important, ladies and gentlemen. For now, you just need to know that for objects moving horizontally, you focus on A and delta X. I don't want to say only in grade 10 that's where you use A as acceleration and delta X as displacement or distance. Reason to that is because when you're in grade 12, you might need to use both G and A, delta Y and delta X in one question, where you're confronted with a scenario that involves two cases where you've got an object falling and you've got someone running to catch that particular object which could be falling. In most cases, they use a camera, where a cameraman standing up the building in either in the balcony drops a camera, and someone who's walking notices that a camera is dropping, and they try to run as quick as possible in order to catch that particular camera, where a question may be, will that person be able to catch it, or by the time when they get to where the camera is falling, will it hit the ground before they catch it? So ladies and gentlemen, we'll get to those type of questions, but for now you just need to understand how I'm trying to explain the difference between the two. Okay, so obviously, ladies and gentlemen, we know this is G, which is what, 9.8 meters per square second. Okay, so this is the gravitational acceleration. This is the acceleration due to gravity. That's why it's the G for gravity. Okay, very, very much important, ladies and gentlemen. And remember, when we're dealing with objects falling or being thrown vertically upwards, that's where we use delta Y. Remember, on the Cartesian plane, the vertical line is represented by Y. Okay, so for you to easily understand, ladies and gentlemen, let's refer to the Cartesian plane to say for objects moving up and down, we use delta Y to represent the distance or the displacement. Okay, and then for objects moving horizontally, we use delta X to represent the displacement or the distance. Okay, I assume at this stage, ladies and gentlemen, you're able to understand the difference between the two. So now that we're in grade 12, or this is a grade 12 lesson, we focus on delta Y and G. Okay, ladies and gentlemen, let's now move to the second formula. Obviously, that one, I assume at this stage you'll be able to fully understand you'll be able to fully understand how they represented that formula using the old the old symbols. Obviously, it's going to be v squared, which is equals to, this is u squared plus 2 acceleration change in x, okay, or just x. Very, very much important, ladies and gentlemen. Otherwise, in some textbooks, you might find that it's not even represented by letter x, but it's just s. Okay, s, which represents the distance or displacement. Okay, very, very much important, ladies and gentlemen. So now, moving to the next one, obviously that one over there, ladies and gentlemen, that means if the distance is represented by s, then that means this is s, which is equals to v initial. It was represented by u multiplied by time plus half acceleration time squared. Okay, so ladies and gentlemen, in short, what I'm trying to explain to you is that if you've got an old book that you use to study, do not get confused, ladies and gentlemen, where in some textbooks they represent those formulas using the new symbols, and in your textbook, they're using the old symbols. Okay, do not get confused, because once you understand both the symbols and you understand their history, then it becomes a bit better for you, to confidently study using any textbook. Okay, ladies and gentlemen, moving to the last formula, you've got obviously S represents the displacement of the distance, which is equals to, that is V initial, which is going to be U plus V, ladies and gentlemen. All of this divided by 2. We put it in brackets because we want to multiply it by the time. Okay, very, very much important, ladies and gentlemen. So that means even if this formula is written as T multiplied by U plus V all over 2, it's still valid. Okay, so in this case, there's no need to put in brackets because that T comes before all of this. Okay, so the reason why in this case they've put it in brackets is because that time is written on this side. Okay, so that means this comes first, followed by T. Very, very much important, ladies and gentlemen. Okay, so guys, let's quickly try to have a look at something. So if you can check, ladies and gentlemen, each and every formula has got 4 variables. Okay, what are those variables? Remember, guys, at this stage I might be using these old, let me just write it to say old symbols, and over there we've got new symbols. Okay, so ladies and gentlemen, in terms of the variables, or what is it, the quantities. Okay, so in terms of the variables or the quantities, when I say each formula has got 4 quantities or variables, these are the quantities that I'm talking about. V final, that is a V final. It's quantity number 1, you've got quantity number 2, 3, and 4. Okay, let's check on the second formula. This is V final, V initial, this is a acceleration, this is the distance. It's 4, ladies and gentlemen. This is the distance, it's 1, then you've got 2, 3, 4, time, it's there. So that means this time is the same as that time. Okay, so we won't have to repeat it. So I'm saying in each and every formula you've got 4 variables. Let's have a look at this one. It's 1, 2, 3, and 4. Okay, ladies and gentlemen, now that we have noticed that we've got 4 quantities of variables in each and every formula, then what is the difference, ladies and gentlemen? Let's have a look at this formula. Okay, so if you can check, in this formula we don't have what is it? We don't have delta x, which is S, or we don't have delta x, or otherwise we don't have delta y. Okay, I hope you fully understand the difference between delta x and delta y. Remember, delta x is for objects moving horizontally, like someone riding a bicycle, someone driving a car, someone walking, someone skating, whatever, ladies and gentlemen. Delta y, that's when an object is thrown vertically upwards. It's when an object is being thrown vertically downwards, an apple from the tree falling downwards, and what else, ladies and gentlemen? Some of additional examples, that's when you will notice when we solve problems related to this chapter. Okay, very, very much important, ladies and gentlemen. So now that means this formula, ladies and gentlemen, it's been used to calculate the final velocity, where you are given, or you have the initial velocity, acceleration, and time, where you don't need the distance. Okay, so that means if you can have initial velocity, if you can have acceleration, if you can have the time, you can only be able to calculate the final velocity of that particular object. Okay, and remember, guys, in place of acceleration, obviously for objects moving up and down, this is where you can replace that A by G. Okay, that A by G, ladies and gentlemen, that A by G. Okay, very, very much important, guys. It just depends on the type of problem that you're dealing with. Okay, so now moving to the next formula, ladies and gentlemen, we've got V final, we've got v initial, we've got acceleration or gravitational acceleration, and the distance. What is it that we don't have, ladies and gentlemen? In this case, we don't have the time. Okay, very, very much important, ladies. So that means this formula can be used to calculate the final velocity of a moving object, where you know its initial velocity, you know its acceleration or gravitational acceleration, and the distance of that particular object. Okay, where you don't have or you don't need the time. Very, very much important, ladies and gentlemen. So now let's move to this one. I hope we are all together, ladies and gentlemen. So now in this case, we've got the distance. Remember, guys, the same explanation applies to the new symbols. Okay, very, very much important. So for someone who's listening or watching attentively, you are immediately able to see that there is no difference. The same thing can be explained on those formulas over there. Okay, so now in this case, we've got S, which is either changing X or changing Y in the new symbols. So now this is equated to U, which is the initial velocity multiplied by time plus half acceleration or gravitational acceleration. You know the difference, ladies and gentlemen. This is multiplied by time squared. Okay, so ladies and gentlemen, what is it that we don't have on this equation? So it seems like a V final or just V, it's what we don't have. So that means, ladies and gentlemen, this formula helps us to calculate the distance or displacement covered or traveled by a particular object, where we only know its initial velocity and the time taken to cover that distance, plus half of its acceleration multiplied by the time. Okay, obviously time squared, ladies and gentlemen. So guys, moving to the last equation, this is where we calculate the distance covered or the displacement, where we know the initial velocity of that particular object and its final velocity, all of that divided by 2 multiplied by time. So ladies and gentlemen, what is it that we don't have on this equation? That is the acceleration or gravitational acceleration, ladies and gentlemen. Okay, very, very much important, guys. Very, 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 very much important. So remember, guys, this gravitational acceleration is constant at 9.8 meters per second squared. Okay, very, very much important, ladies and gentlemen. But this acceleration of objects moving to the right or down, it's not constant. Okay, it depends on each and every situation. Very, very much important, ladies and gentlemen. I assume at this stage we're still on the same page. Okay, so guys, without any waste of time, let's now go through the steps to using these equations. I assume at this stage everyone understands what I've been explaining over there. In case if you missed something or you didn't understand a certain portion of this explanation, please do make sure to just drop a comment. Otherwise, you can text on that WhatsApp number. Let me see, 0748663830. Okay, you can just WhatsApp that number and refer to a portion that you did not understand. Okay, so now let's proceed with steps to using these equations. Ladies and gentlemen, I'm just going to quickly try and explain in the simplest way. Okay, so in case if you're writing the notes, ladies and gentlemen, the best thing to do when you use these equations is to draw a diagram of the motion of the object. Okay, so most importantly, draw the diagram. Okay, so in case if an object has been falling downwards or it's moving, it's a car, traveling or moving from east to the west, it's better to have a diagram that represents the motion of that particular object. Okay, so remember guys, you can only do that once you understand how the diagrams are being interpreted and how they are being drawn. Okay, on the next video, that's where I'm going to teach you how to interpret the graphs. Okay, so it means in some instances you might be given a graph where they want you to either calculate or tell what is the final velocity of a particular object which is represented, let me say, which its motion is represented in a form of a diagram or a graph. Okay, very very much important, ladies and gentlemen. Not necessarily the graph that needs to be drawn, but the diagram, ladies and gentlemen. Let's say an object, this is a flat, okay, this is a balcony, and there's an object which is dropped from the top going down. Okay, so in case if they say it's been dropped, you must know its initial velocity. If they say it hits the ground maybe after 2 seconds, then you write it down. This is the diagram. Maybe they want you to calculate the final velocity. So ladies and gentlemen, this object, it's either it's been thrown or dropped. Okay, different ways being used: dropped or thrown vertically downwards. So these two ways, ladies and gentlemen, they've got a major influence on your initial velocity. Okay, I'm going to explain that shortly. So this is the diagram that I'm actually referring to. Okay, so when it comes to the graphs, it's going to be a different story, of which I'm going to teach you in detail on the next lesson. So please do make sure that as soon as you're done watching this lesson, you don't miss the next lesson. Okay, secondly, ladies and gentlemen, very very much important, identify each stage of the motion. Okay, so where that's where the acceleration has changed. So for you to identify each stage of the motion, it helps you to notice where the acceleration changes. Okay, obviously you might find that there's a car which is traveling in that direction at 2 meters per second. Let me just say not 2, but let me say 40 kilometers per second. Not even a car. I'm just trying to be realistic, ladies and gentlemen, because 2 meters per second for a car, it's very very slow. Let's say someone is driving it's riding a bicycle. Okay, that's a bicycle, ladies and gentlemen, 40 meters per second. Then from there, let's say it's traveling in that direction, and they say after covering a distance of, let's say, 700 meters, okay, it changes its speed. It's now slowing down. For example, it's now slowing down. It's now 10 meters per second. Okay, so what we are trying to say here, ladies and gentlemen, can you see? You're done with the first step of drawing the diagram, which is, this is the diagram. So now you need to identify each stage of the motion where the acceleration has changed. So you can see this is another stage of its motion where it was traveling at 40 meters per second. Then after traveling for 700, maybe for another 300 meters, it travels at 10 meters per second. Okay, so that means obviously here it has changed acceleration. So if it was traveling at 40 meters per second and then it starts to slow down, then it means its acceleration, it's now decreasing. Okay, that's why they use the word deceleration. But otherwise, if it changed from 40 to a speed greater than 40, let's say 60 meters per second, then that means the acceleration is now positive. Then it means it has accelerated. It was just traveling at that speed, now it has accelerated some more. Okay, very very much important, ladies and gentlemen. So to make a comment on that, as part of your notes, can just say identify each stage stage, okay, where acceleration has changed. So let's say where acceleration has changed. Ladies and gentlemen, I know you're going to write neatly. Okay, so guys, I'm just writing in this way so that we save some time. Okay, very, very much important, ladies and gentlemen. You need to choose a direction, ladies and gentlemen. Choose direction. Choose direction and use the same convention throughout. So what I mean by that, ladies and gentlemen, is that if you've got an object which is, which is being thrown vertically upwards, okay, choose upwards as positive. That means when that object returns down, obviously it's going to go up, it momentarily stops and then changes direction and comes down. So when it comes down, the opposite of a plus, it's a minus. Okay, very, very much important, ladies and gentlemen. So remember at all times to choose direction. So in my case, ladies and gentlemen, the first direction in which the object is moving, I take it as positive in most cases. For example, doesn't necessarily mean at all times for objects going upwards, there will be positive. For objects going downwards, there will be negative. Obviously, if there's a flat and there's someone on the balcony and they drop an object vertically downwards, so the initial movement or motion of this object is downwards. So that means for me, downwards will be positive in this case. Okay, and then if it goes down, let's say it's a tennis ball, it hits the ground and then it bounces upwards. So that means when it goes up, it will be negative. Okay, can you see the difference between the two, ladies and gentlemen? In this case, an object was thrown vertically upwards, so that means upwards is the initial motion of this object, of which I take as positive. But in this case, it's been thrown or it's been released or it's been dropped from a balcony. Its initial velocity is downwards, then I take it as positive. Very, very much important, ladies and gentlemen. I hope you fully understand. Okay, same applies for objects moving horizontally. Okay, so now on D, ladies and gentlemen, you need to record the information given. Okay, record the information given. Information given. Okay, you will have a better understanding of all of this, ladies and gentlemen, when we get to a stage where we deal with problems. I think on a list of what I'm supposed to teach you guys under this lesson, that part is included where we need to solve or have some practice questions. Okay, you might find that they say, there's a tree, this is a tree, this is the ground, this is an orange, let's say it falls. Okay, as it falls, they say it hits the ground after 2 seconds. Okay, so obviously, ladies and gentlemen, because it's falling freely from the tree, that means it has got an initial velocity of which you must know. Okay, they tell you that it took 5 seconds for it to hit the ground, so that means the time is 5 seconds. Okay, and maybe they say it hits the ground at a velocity of, let's say its velocity is 13 meters per second. Okay, so a question that they might ask you in this case, ladies and gentlemen, is that how long is that part from where the apple or the fruit fell, that distance from that point to the ground. Okay, that's the question that they might ask you to say what is why. Okay, so that's why, ladies and gentlemen, we are saying it's very, very much important that you record the information given. Okay, so it helps you to know how many factors you've got. Remember, guys, in each and every equation we've got 4 quantities or 4 variables. So this should be your first variable, your second variable, and then this should be your third variable. You need the 4th variable, of which is G, which is constant at 9.8. So when you have 4 variables, ladies and gentlemen, you know you've got all the information you need in order to calculate anything, ladies and gentlemen. But you just need 3 variables in order to calculate the 4th one. Okay, very, very much important, ladies and gentlemen. Remember, even if, for example, you don't have V initial, but you have V final, you have time, you have G, you can still be able to calculate its initial velocity. Otherwise, if you've got 1, 2, 3, it seems like you might need to just choose a formula over there to see if you can be able to calculate either this distance or otherwise the initial velocity. Guys, I'm just giving you an example here just so that you understand. Okay, actually, in preparation to what we'll be doing, that was D. Let's see, E. Ladies and gentlemen, select the correct equation and solve for the unknown. Okay, select equation and solve the unknown. Remember, guys, you don't necessarily need to write exactly what I'm writing. Just write something that you're going to understand in the next 40 years. Okay, do not just write because I'm writing. That's why I'm encouraging you to watch these lessons 3 times, and then from there you write your own notes in the manner in which you're going to understand them. Okay, but most importantly, do not deviate from what I'm explaining to you guys. Otherwise, I'm saying do not write something completely way out, or by trying to write your own steps. You can still do that, but you'll basically be going through all of these steps. Okay, but it's better to just stick to one explanation that you fully understand. Okay, so you select equation and solve for the unknown. I think I've explained that on this part where you need to record information given. Okay, obviously you just need 3 quantities to solve for the 4th quantity, which will be the unknown. Okay, very, very much important, ladies and gentlemen. And lastly, most importantly, ladies and gentlemen, please do include the units and directions in your answer. Okay, the units and directions in your answer. Okay, very, very much important, because for you to write the unit, ladies and gentlemen, is considered when you provide an answer. If you say velocity is equals to 2, ladies and gentlemen, we're not sure if this V represents the volume. Okay, we're not sure if this V represents it could be anything else. Okay, but the moment you say meters per second, then we know, oh, this guy is actually calculating the velocity. Okay, the speed, ladies and gentlemen, same unit. Okay, the distance, let me say delta y, ladies and gentlemen. If you say 40 meters, because of that meters, then we know you are calculating the distance. Okay, most importantly, ladies and gentlemen, you need to know which variables are vector quantities and which variables or which quantities are scalar quantities. Okay, for example, velocity, it's a vector quantity, which means it has the magnitude and the direction. Remember, that positive for objects moving upwards. If your final answer is a positive number, then you just write upwards. Okay, if your final answer maybe it's negative, then you just write downwards. It depends on how you chose your signs. Okay, so that means if you choose your positive to be upwards, for every answer that you get, as long as it's a positive value, then you just write upwards. In some cases, when they mark, they give you a mark for 2 meters per second, and again they give you a mark for the direction. Otherwise, if you don't write the direction, you might lose a mark for that. Okay, very, very much important, ladies and gentlemen. But remember, quantities like time, they don't have directions. It's just 4 seconds, 4 minutes, or whatever, then it's done. Okay, very, very much important, ladies and gentlemen. That's why you need to stick around with me for some time until we get to that stage where we solve real problems. Okay, very, very much important, ladies and gentlemen. The last thing that I want to explain to you guys, it's some concepts or terms that you need to remember, and again to understand what they mean under this chapter. Okay, very, very much important, ladies and gentlemen. Remember, I'll just write it down. They say, remember guys, with some exclamation marks over there, remember, starting from rest, okay, starting from rest means, ladies and gentlemen, your initial velocity is equals to 0, okay. Starting from rest, it means your v initial, or with the old symbol, is going to be u, it's equals to 0. What 0? 0 meters per second, okay. Very, very much important, ladies and gentlemen. Just write it down next to that one to say starting from rest means v initial is equals to 0. In your notes, ladies and gentlemen, just write v initial because this is an old symbol. I'm just teaching you so that in case if you're using an old textbook, okay. Very, very much important, ladies and gentlemen. Comes to a stop means v final, or just v using an old symbol, it means 0 meters per second, okay. Very, very much important, ladies and gentlemen. Very, very much important. So I assume at that stage you fully understand what I'm trying to explain to you guys, okay. Obviously something comes to a stop because it was moving. That's why they say v final, okay, because obviously if it's moving, it has been moving, it comes to a stop. That means when it comes to a stop, its v final is equals to 0 meters per second, okay. Obviously that means if it comes to a stop, it had an initial velocity of which it might be a certain number, okay. So ladies and gentlemen, I hope you fully understand that part, okay. Guys, slowing down, these are the terms that they use under this chapter, ladies and gentlemen. Or some, whatever that you're given in the statement where they say it's slowing down. Very, very much important, ladies and gentlemen. For something which is slowing down, it means the acceleration is negative. It means it's actually decelerating, okay. So that means the acceleration, it's negative, okay. By being negative, the shortest way to explain this is just to say it's less than 0, because obviously anything which is negative is less than 0, ladies and gentlemen. So that means for a car which was moving fast or at constant velocity, and then now it starts to slow down, it will eventually come to a stop, okay, which means its final velocity is equals to 0, and as it accelerates, ladies and gentlemen, obviously we no longer use the word accelerates, but it decelerates, okay. So that means if you substitute acceleration, let's say maybe they say it decelerates at 2 meters per second squared. So what it means, ladies and gentlemen, is that when you substitute it in those formulas there, you substitute as negative 2 meters per second squared. Why negative? Because it decelerates, okay. It's less than, its acceleration is less than 0, so you make it less than 0 by substituting a negative sign over there, okay. So guys, I assume you fully understand. So ladies and gentlemen, the other one that they like using is constant velocity, okay. Constant velocity, what does it mean, ladies and gentlemen? It means the acceleration is equals to 0, okay. Very, very much important, ladies and gentlemen. It means the initial velocity is equals to final velocity. Using old symbols, you'll say u is equals to v. That's when the the speed or the velocity is constant, okay. So what it means, ladies and gentlemen, you just have something which is just moving constantly, okay. It's moving constantly. So the reason why acceleration is 0 is because it's not increasing its speed, okay. It's just moving constantly. If when it passes house number 1, it was traveling at 20 kilometers per hour, or let's say, or maybe 40 meters per second. When it passes house number 5, if it is still traveling at 40 meters per second, it means its velocity is constant. Okay, it's not increasing, it's not decreasing. Otherwise, if it's a car, for example, if it's still traveling at 20 kilometers per hour when it passes house number 5, means its velocity is constant, ladies and gentlemen. So that means its acceleration, it's not increasing, it's not decreasing. That's why it is equals to 0. So obviously, as it passes house number 1, its v initial, it was that or this. As it passes house number 5, its velocity is still the same as its initial velocity. Ladies and gentlemen, I hope it makes sense. Okay, remember guys, if you're getting confused or you feel like there's something that I'm not clearly explaining, you know what to do. Okay, ladies and gentlemen, most importantly, please do make sure that you convert the units. Okay, unit conversion or conversion of units. Let me just say convert to SI units, international symbols. Okay, for example, ladies and gentlemen, if you are given time in hours, okay, in hours, convert it to seconds, because in physics we measure time in seconds. Okay, very, very much important. If you're given distance in kilometers, in millimeters, in centimeters, ladies and gentlemen, convert all of this to meters, because in physics we measure distance in meters. Okay, guys, if you're given the velocity or speed in kilometers per hour, okay, ladies and gentlemen, convert this to meters per second, because we measure speed or velocity in meters per second as far as physical sciences is concerned. Very, very much important, ladies and gentlemen. I hope you enjoyed this lesson, and guys, please do make sure that you don't miss the next lesson, because this is where I'm going to teach you how to interpret the graphs. Okay, very, very much important, ladies and gentlemen. From there we should do one or two examples where we just do some practice questions. Okay, so ladies and gentlemen, I hope this was a very fruitful lesson for you. And let me see, I'm just trying to think if there's something that I've missed of which you might find valuable for me to explain. Okay, remember, ladies and gentlemen, in this case I was actually referring to objects moving left or right. Okay, so now that you must remember all of this, ladies and gentlemen, let me just try to check what I can explain in terms of objects moving up and down. Okay, nothing there's nothing much different, but you just need to know that ladies and gentlemen, let's say this is a flat, this is a balcony. Okay, in this case, remember, you've got gravity, where the gravity is 9.8 meters per second. Okay, remember, this one is constant. The gravitational acceleration is constant. Okay, so in this case, an object could be falling, very, very much important, ladies and gentlemen, or otherwise being released. Okay, so when an object falls vertically downwards, okay, let's say there's someone there, our friend over there has got an object, and then they just let it fall. Okay, so it freely falls. So as it falls, ladies and gentlemen, that means its initial velocity is equals to 0. Okay, same thing when an object is being released. Okay, but remember, this is free fall. Okay, free fall. So a free fall, this is a case where it's just falling freely. So free fall is best used in cases where maybe it's an object or a fruit falling from the tree. Can you see, ladies and gentlemen, it falls freely. Okay, so that's a free fall. And then an object being released, is the same as that one where we've got our friend over there who's releasing that tennis ball. Okay, very, very much important, ladies and gentlemen. So now again, you might have the same guy, ladies and gentlemen, throwing this object vertically downwards. Okay, thrown vertically downwards. Very, very much important, ladies and gentlemen. Thrown vertically downwards. Okay, so why is it important for them in questions to say thrown vertically downwards or thrown vertically upwards, ladies and gentlemen? What is special about that vertical is because we are not dealing with objects which have been thrown at an angle. Okay, because otherwise if it's been thrown at an angle, those formulas won't apply. Okay, that's why we say motion in one dimension, ladies and gentlemen. It's been thrown vertically downwards. Okay, so for objects moving left and right, that means we are dealing with objects moving horizontally, not at an angle, ladies and gentlemen, not at an angle. Okay, but horizontally, either from west to east, from east to to west. Doesn't matter in which direction the object is moving. Okay, very, very much important, ladies and gentlemen. So obviously for an object which has been released from a certain height, ladies and gentlemen, in this case is represented by a change in y. This object, as it hits the ground, it's going to have a final velocity, which is something that you might need to calculate. Okay, very, very much important, ladies and gentlemen. Might have something that you might need to calculate. Okay, and obviously your g is that. In some instances they might give you the time, or otherwise you might not be given the time and be expected to calculate that particular time taken by the object to fall from that height to reach the ground. Okay, not only are we going to be dealing with objects being thrown, released, or freely falling from the top. In some instances we'll be dealing with objects which will be thrown vertically upwards. Okay, otherwise you might be in a situation where there's that balloon, ladies and gentlemen. These big balloons. I'm not good in drawing, ladies and gentlemen. I'm not really sure of how I'm going to draw this one, but I hope you fully understand what I'm talking about. Because okay, let me just draw it this way, ladies and gentlemen. And there's someone inside that balloon. Maybe they're using their phone to capture some, take some photos. Okay, and let's say this is the ground, ladies and gentlemen. So for some reason this balloon, this hot air balloon, is moving upwards. Okay, vertically upwards, and we've got our friend in there enjoying the view, and they're taking some photos with their phone. Okay, by mistake their phone, it happens to fall. Okay, so now that phone is falling vertically downwards. Okay, so ladies and gentlemen, as it falls, or as it mistakenly falls, this object is going to have an initial velocity at that stage. Okay, and because this object is already moving vertically upwards, the initial velocity of this object is not being thrown vertically downwards. It just happened to fall by mistake. So it's more like it's being released mistakenly. Okay, so what happens in this case, if this was falling, it was moving upwards at 20 meters per second, we'll see when we deal with this type of problems. You might find that the initial velocity of this, even though in this case it's being released by mistake, its initial velocity, it's not zero, because this object was moving vertically upwards at 20 meters per second. So before it goes downwards, it will just go up and then from there down. Okay, up at 20 meters per second, then it reaches its maximum height, then it starts going down. Okay, ladies and gentlemen, luckily we've got another friend who was just walking, okay, from there going in that direction. Okay, can you see now we've got objects falling vertically up and down, and again we've got an object moving you know horizontally to the right in this case. Okay, so now you might find that this is where that object is going to hit the ground, and this person is maybe 10 meters away. Okay, so now you find that the height from where it was being mistakenly released, let's say it's 75 meters. Okay, they might tell you that it takes certain time for this object to hit the ground. Okay, you obviously know, ladies and gentlemen, that is going to have a v final as it hits the ground, of which it might be given, it might not give it to you. Okay, and most importantly, you know, for falling objects, g is equals to 8.9 meters per square second. It doesn't change. Very, very much important, ladies and gentlemen. So now in this case, this is where you might need to use to represent these formulas in two ways. For this guy who's walking horizontally, you might find that in case of delta, you use, in terms of distance, you use delta x. Very, very much important, ladies and gentlemen. And then you use the acceleration. Okay, but for this object which is falling, you use gravitational acceleration on the formula, and again, in terms of the distance, you use change in y. Okay, very, very much important, ladies and gentlemen. And again, to take into account the directions, to say you've got a positive direction and a negative direction. Okay, so these are the type of questions that you'll be dealing with in your exams. So you better make sure that you watch all of my lessons in order to fully understand this type of questions. I am telling you guys, you will never go wrong. Okay, so guys, this is in short what I wanted to actually explain to you guys. But for now, I think this should bring us to the end of our lesson for today. I hope we'll still be together on the next lesson. Ladies and gentlemen, thanks very much for joining. My name is Desmond, and I'm out.